Hello there and welcome to today's class. For today's class, we'll be looking at the solution to experiment 11 of the organic chemistry manual. For this one, we'll be looking at the qualitative analysis of inorganic compounds. Now, first things first, before we look at this, let's understand what qualitative analysis means. So when we say the qualitative analysis of inorganic compounds, what exactly does qualitative analysis mean? Now, I'll give you a definition. Okay, so by definition, we can say qualitative analysis is the determination of non-numerical information about a chemical species, a reaction, etc. So when it comes to qualitative analysis, we are not really calculating we're not calculating the numerical information such as the molarity, such as the volume. No, we don't calculate it. Instead, we do what is called the non-numerical information about a chemical species, a reaction, etc. So when we say non-numerical information, we mean the type of perhaps cation or anion present. All right, we don't really consider the volume or the concentration. All right. Also, it is a branch of chemistry which deals with identification of elements or grouping of elements present in a sample. All right, so when it comes to qualitative analysis, a major task here is to identify the kind of elements present in a given species. So usually you'll be given a sample of a substance and you'll be asked to identify what kind of element or group of elements or what kind of compound is present there, and you get this using some inferences. All right. Okay, so fine. Having said this, let's go straight into the task. All right, so here's what to note. The qualitative analysis of compounds can be divided into four stages. All right. The first one is called the preliminary test. The second one is making a solution of the substance under test. The third one is the test for cations, and the fourth one is the test for anions. All right. For this practical, we'll focus more on the test for cations and anions. Now, when we say cations, what do we mean? Cations are simply ions that have positive charges. All right. Example: when you have something that looks like Ca2 plus, this is a cation. It's a cation because there's a positive charge attached to the element there, which is calcium. Also, you have NH4 plus, which is ammonium ion. This ammonium ion is also a cation because it's positively charged. Other cations include the magnesium ion. So you have this magnesium ion is also a cation. You have barium ion. Barium ion is also a cation, and etc. So when we say cation, we mean ions that have positive charges. Okay, so let's look at the next one there. So when we say anions are simply ions that have negative charges. All right. So when you have ions with negative charge, it's called, when you have an ion with a negative charge, it's called an anion. Example, you have this. So um tetraoxosulfate 6 ion. This is an anion. It's an anion because this is negatively charged. Also, you have this one here. Right, so this is also an anion because it is negatively charged. So when you have probably a radical such as this, or an element that has a negative ion or a negative charge, it's called an anion. So simply put, cations are ions that have positive charges, while anions are ions that have negative charges. All right, so they said the purpose of this preliminary test is to provide clues to the nature of the substance under observation. Listed below are some of the preliminary tests, so you can go through the study of all of what you have there. I'll just focus more on how to fill up the practical manual. So let's go straight to the exercise that was given. All right, so exercises. Let's start with exercise 1. Exercise 1 here says the following exercises assume you are familiar with the sample methods of qualitative analysis of inorganic compounds just discussed. For each exercise, state the letter designed to the substance under investigation and then divide your page into 3 columns: test, observation, and inference. So you can see this. I've divided mine into three columns: the test, the observation, and the inference. Okay. Next up, it says, next up they say some substance A is a single compound. Okay, so first things first, they're giving us a hint that A is a compound. What next? Number one says heat. So number one says heat a small portion. Number one says heat a small portion sample of A in a glass tube, in a glass test tube. Identify any gas evolved. All right. So this one was done, but I don't think they actually identified the gas evolved. All right, number two says make a solution of sample A. So this becomes my first task. So when you say make a solution of sample A, what does it mean? It means I'm combining sample A with water, that's H2O. So my first thing here under test, I'll write sample A. So sample A plus water, that's H2O. So you can write plus H2O or plus water, which one you feel okay with. Now, when I did this for my own observation, this was a clear solution. All right, it was a clear solution. So what this means was that sample A actually dissolved in water, and it gave me a clear solution. So what can I infer? So if sample A dissolves in water and gives me a clear solution, what can I infer? By inference, it's just like you're making a suggestion. All right. What can you suggest, or what can you say about it? What do you think about it? That's what inference means. So if sample A can dissolve in water, hence I can infer that sample A is soluble in water. So I can say sample A is soluble in H2O, in water. All right, so that's my inference for this one here. Let me look at the next task there. All right, so we've answered this one here, which is make a solution of sample A. Number three says test solution A. All right, so it's now solution A with the first one there is dilute HNO3, which is hydrogen trioxynitrate 5 acid, or simply I think that's nitric acid. All right, so let's get this. So I'm testing solution A with HNO3. That's dilute. So the test will be solution A. So you can say solution A plus, they said dilute. So I'm going to write dilute HNO3. So I have this. If there's no space to write dilute, you can just write DIL, like DILHNO3. This still works. Okay, so I'm just saying if there's no space for the test, if there's no space, enough space here under the test, you can write DILHNO3 instead of the full dilute. It's still correct. All right, so what next there? When I did a solution of sample A and dilute nitric acid, I also found a clear solution. All right, I found a clear solution. Clear solution. So it still dissolved, and I couldn't really find anything there. So I'm calling it a clear reaction. So what's the inference? I can just probably infer that there is no reaction, and that would mean that probably tetraoxosulfate 6 ion is present. All right, that's my inference. That's this is present. So I am inferring this. All right, because there's a clear solution. So this is my inference. So what's the next thing there? Let's look at the next task there. The next task there says, that's 3II, says solution A, test solution A with II says dilute sodium carbonate. When we did this experiment, there was no sodium carbonate there. So instead, we're asked to use sodium hydroxide. All right. So it becomes solution A plus sodium hydroxide since sodium carbonate was not available. So I'll now say solution A plus, it was supposed to be sodium carbonate, but there was no sodium carbonate. Instead, we use dilute sodium hydroxide. So that means I'll come here, I'll write plus dilute sodium hydroxide. That's this. All right, so I have this. So it depends on your year. So if in your own year, maybe when you did this, the sodium carbonate was actually provided. So if it was provided, you write down what you saw. That's your observation. For mine, we use sodium hydroxide. All right. So the observation here was that a white precipitate, all right, white precipitate, I'm writing precipitate as PPT. A white precipitate was formed. So this is what I saw when I mixed these two. So when a white precipitate is formed, what can you infer? Now let me show you how this inference works. This inference, they're not just guesswork. Let me show you something. If you go back to your manual and look at the test for anions and cations from your manual, let me show you something. All right, there's this page here that talks about testing for cations. First things, if you look at this, it said when you test using sodium hydroxide, which is what I used actually, since the sodium carbonate was not available, we use sodium hydroxide. If you look at this, it said um, when white precipitate, which is soluble in excess, this was formed, we said what could occur here could either be aluminum ion, lead ion, tin ion, or zinc ion. All right. So if I'm having the white precipitate that I saw, that means any of this is present. So it means it could contain either aluminum ion, lead ion, tin ion, or zinc ion. So my inference is that it could be aluminum ion, lead ion, tin ion, or could be zinc ion. All right, so I have this. So these are like, this is like my inference. So what's next there? The next one there says, um, test solution A with silver nitrate. All right, silver nitrate is AgNO3. All right, so I'll come here and say solution A plus silver nitrate. You're free to shorten this if there's no space in your manual. Like if the space in your manual is not big enough, you can simply write A plus AgNO3. This is still correct. All right, for me, since I have enough space, let me write in full. So in full, I'll just come and write solution A. So this becomes solution A plus silver nitrate, which is AgNO3. All right, what did I observe from this? Now, when I did this stuff here, I observed that a white precipitate, was formed. All right, so this is my observation. So when this is formed, what's my inference here? From here, I can infer that zinc ion is probably present. Okay, I'm write this here. Zinc ion probably present. So I write Zn. Zinc ion is probably present. Again, this idea, just like I showed you, if you go back to your manual, you see something like this there. That's if you have the silver trioxynitrate reactions there. All right, so here's my inference. What's the next thing there? I think this is the last one there. Last one here is barium nitrate. Barium nitrate is BaNO3. So I would get solution A plus BaNO3. So I'll have solution A solution A plus barium nitrate. So I have this. All right, when I combine this, what happens there? What I observed was that a bubble evolved. Okay, so bubble evolved. Not just this, and a dense white precipitate and a dense no space here. Let me go up and bring that. So a dense white PPT, that's precipitate, is formed. So this was my observation, is formed. All right, so I have this. So what's my inference? So if this happens there, what is present here is actually the trioxo. What's actually present here is a tetraoxosulfate ion. So that means this confirms that tetraoxosulfate 6 ion is present. All right, so that's it. So after this, you'll be asked to put your conclusion. All right, so put your conclusion. So if you have all of this inference, what do you think sample A is, or substance A is? So what's my conclusion? To get your conclusion, just go back to all my inferences. If I see this, I can see that now. This is how this works. First things first. Um, before you get your what's it called? Before you get your compound, notice that a compound is formed when a cation being positively charged combines with an anion being negatively charged. All right. When they combine, they form your compound. I'll give an example. Let's say we want to form water using hydrogen ion and oxygen ion. First things first here is that for this one here, a compound can be formed because these two can actually interact together. These two can react, and they can react because they have opposite charges. And we've said when you have opposite charges, do what they attract. So when it comes to these two combining, the number here comes down here, the number here comes down here. Please, the sign does not come down, there's just a number. So this gives you H. The number here is 2. 2 comes down this way here, becomes H2. Then I have this one here, O for oxygen. All right, the number here is plus 1. So 1 comes down here. And that becomes, of course, I can take off the 1. That becomes H2O. So this is like this, the simple concept on how ions combine to form compound. One more thing, let's say I have something like calcium ion, Ca2 plus, combining with oxygen ion, that's O2 minus. Please observe something here. For this case here, you observe that we said these two here will come down here. That becomes Ca2. I have oxygen, that's O. Also, this 2 comes down this way here. I have 2. In a case where the numbers are the same, like 2 and 2, they cancel out, and I have a compound that looks like this. So what I will have here is simply CaO. This becomes the compound. Why? Because the pairs are the same and they cancel out. All right, with this concept, let's go and complete the table. So in conclusion, what compound do we have here? First things first, I can see that zinc appeared twice. That means probably the cation here is zinc. So I'll have zinc, Zn2 plus, combining with, I'll look for the anion, which is a negatively charged ion. For this, I'm seeing SO42 minus tetraoxosulfate 6 ion and SO42 minus tetraoxosulfate 6 ion. So it's twice. That means probably that's what we have here. So plus SO4 2 minus. Let's combine this to form a compound. From here, I'm having first thing Zn, which is zinc. These two from here comes this way. Of course, these two can combine since they are opposite. They have opposite charges and they can attract. So Zn2 and then SO4. These two here also comes this way, comes to this position. Now, since SO4 is a radical, that means it has more than one atom of an element here. You have the 2 under bracket. So I have this 2. So observe the way I work with this, because it's not just an element. It's more like two different, you have atoms of two different elements here. So it becomes this. In this case here, since they are still both the same number, 2 and 2, 2 will cancel 2. So with this now, the compound I have here probably is zinc tetraoxosulfate 6. So I have this. So this would be the compound available here. All right, so we've identified the compound. What next? Let's now fill up our solution. So in solution, we can say the solution of sample A. So we can hear in conclusion, we can say the solution of sample A is zinc sulfate. So it's zinc sulfate. So that's called zinc sulfate. Or you can say the IUPAC name is zinc tetraoxosulfate 6. That's it. That is ZnSO4. All right. So this is how we fill exercise 1, and this is how this is done. All right, let's go to exercise 2. All right, so let's look at exercise 2. For exercise 2, I have sample B. Now, the first thing there, one says make a solution of B in water. So my first test will now be sample B in water. So I'm having sample B. So sample B plus H2O, that's water. My observation here was that a clear blue solution was formed. So I'll say clear blue solution. So that's my observation. So if I have a clear blue solution, what can I infer? Now, usually when you have a clear blue solution, the inference is that a soluble salt is present. So my inference here is that a soluble salt is present. So that's my inference. I'm having this. Soluble salt is present. I'm having this. Okay, what next? Let's look at the next one there. The first thing here, as we just did, was to make a solution of B in water. So you had B in water, which was just sample B plus water. Now that sample B plus water, you're asked to break them into separate portions of this solution. Now to this solution, add sodium hydroxide slowly until in excess. So that solution where you had sample B in water, which is the solution of B, right? Solution of B, said you should add sodium hydroxide. So I'll pour in sodium hydroxide just slowly, little by little, until sodium hydroxide becomes excess. So what I'll now have there is not just sample B, but solution B. All right, test here becomes solution B because it's now sample B in water. So it becomes solution B plus, they said with sodium hydroxide, so plus sodium hydroxide. All right, so what did I observe? I observed that a blue gel was formed. So blue gel is formed. That's my observation. Okay, so what can I infer here? Please, whenever you have that color blue, the inference is usually copper. That means copper ion is suspected. So I suspect that copper ion is there. All right, so copper ion is suspected. Let me see if I can show you that one. Let me see if I can show you that. All right, so you can see this. You can see it here in this page here, the test for cations. You can see that when you have pale blue precipitate, it's a copper ion. So note that when it comes to color, when you see blue, it's most likely a copper ion, right? Copper 2 ion. All right, so I have this. Let's look at the next one there. The next one here is I here says add ammonium solution until it is present in excess. All right, so I'll just, to the other portion that is unused yet, I'll just pour in ammonium solution. That's ammonium in water. Just keep pouring it little by little until it becomes excess. So the next thing I have there is solution B plus ammonium solution. All right, so I have solution B, solution B plus ammonium. Ammonium is NH4, so plus ammonium solution if you want to. All right, that's ammonium solution. So when I do this, what's next there? Now, what I see, my observation here is that blue gel precipitate, blue gel PPT, that precipitate is formed. So this is my observation. Blue gel precipitate is formed. Now, since the color remains blue, I'll still be suspecting that what I have should be copper ion. So I'll say copper ion is suspected. I'll still suspect this. Okay, is suspected. Okay, so I have this. All right, so what's the next thing there? Let's look at the next task there. The next task there is to that same solution B in a separate portion, dilute nitric acid. Now, nitric acid is simply HNO3. All right, so it becomes solution B, the unused solution B, in a separate portion, another portion of it. So it becomes solution B plus nitric acid. So solution B plus nitric acid is HNO3. So I have this. Now, from this, what I saw here was that a blue gel solution was formed. That's the observation I made. So blue gel solution is formed. So when this is formed, what comes to my mind? This is a total or a clear indication that copper ion is present. So I was suspecting that it's there, but this blue gel solution that is now formed is a perfect indication that copper ion is present. But I'm not done. I think the last thing there said, what is it? They said followed by silver nitrate solution. So I'll still add silver nitrate solution. So to this one here, I will now add silver nitrate solution. So more like I'm having solution B plus nitric acid plus silver nitrate. So I had this when I added just nitric acid. I had this. Now let me now add silver nitrate to this. So it simply becomes solution B plus nitric acid, that's this. Now plus they said silver nitrate, so it becomes AgNO3. So I have this. All right, so if I combine this, what happens here now? My observation here is that a white precipitate turning gray purple is formed. All right, white precipitate, white PPT precipitate turning gray purple, uh, turning gray purple is formed. All right, so I have this. All right, so if this is formed, what happens? What's our inference? From here, we can infer that. So what should be here is actually chlorine ion. All right, this shows that chlorine ion is present. All right, so it shows that chlorine ion is present. So with this, I'm done with this one here. My last task is to put in my conclusion. All right, let me get my conclusion. So in conclusion, what can we say? In conclusion, like I said, the solution of substance B, the solution of substance B is what exactly? For here, the cation is copper 2 ion plus the anion is chlorine Cl minus. So how do we form this compound here? Obviously, we said these two can combine because they are opposite charges and they can attract. So it becomes copper Cu. For here, what I have here is 1. The 1 comes here, becomes Cu1, which is something as Cu. Then the chlorine, I have Cl. The 2 from here comes this way, so it becomes 2. So what I have here is copper chloride. All right, so we call it cuprous chloride. Right, so it's CuCl2. All right, so this is my inference using the ions that I inferred. So this should be my compound. So that means substance B is copper chloride. All right, so this is how you answer or these are the solution to the exercises, exercise 1 and 2 of experiment 11. All right, so if you enjoyed this video, please like the video. All right, leave a comment in the comment section. All right, tell us if you enjoyed this video, and also tell us other experiments or other things you'd want us to create content about. I had to create this video because many persons were like, okay, let's do experiment 11, let's do. So I saw many persons commenting that they needed experiment 11, and that's why I had to make this video. All right, so if there's any other thing you want to say, please leave it in the comment section. Also, tell us if you enjoyed this video in the comment section. Also too, don't forget to share this content. All right, so share this video right now to your friends. All right, share to your department WhatsApp group, share to your friends so that they can also learn. And please, if you're new here or you've not subscribed yet, please make sure you subscribe to this channel. It helps us to grow. All right, okay, so one last thing before I go, you can visit my website. All right, my website is this: www.jonahemmanuel.com. All right, so this is my website, www.jonahemmanuel.com. When you go to this website, you see the book section. All right, so you can access my books as well as my courses. All right, I have a book on scholarships. All right, where I shared how I was able to get 7 scholarships as an undergraduate student back then in Nigeria. All right, so if you want to know how to gain scholarship, you're interested, you can as well visit my website, go to the books section, and you get my book. It's a book called Scholarship Roadmap. All right, that's the book. You can get the book called Scholarship Roadmap, and you see how I was able to secure 7 scholarships as an undergraduate. Also, you can get my courses there. Just go to the courses section. You see my different courses there, and you can pick any one you want. All right, thank you very much, and see you in the next class. Don't forget to like, comment, share, and subscribe. See you in the next class.